Okay, so let's answer the problem that I set out in the last one. I want to have a 5-line poem, and I want 3 of the lines to uh, rhyme, and then the other 2 lines to rhyme. And so you might have stopped and said, well, this is some sort of arrangement. The order matters. You know, uh, you know, A, B versus A, B, A, B, A. This is arranging these guys. So, isn't this some sort of permutation thing? Not if I look at it in the right way. The way I'm going to look at it is this. I'm going to, what are the things I'm choosing? I'm going to be choosing 3 lines out of 5 to have A's. So it doesn't really matter which order I choose, if I chose 1, 2, 3 or 3, 2, 1 to have the A's in them. I'm just choosing 3 out of the 5 lines to have A's, and then automatically the other 2 will be B's. The order I choose them in doesn't matter because at the end of the day I just get A's and B's arranged however. So what I'm really doing here is choosing 3 lines out of 5. So my K is 3, my N is 5, and I have a 5C3, which is 5 factorial divided by 3 factorial times 5 minus 3 factorial. That's 5 factorial over 3 factorial times 2 factorial, which is, it's right at the top, is 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial. The 3's cancel out. I'm left with, the 3 factorials cancel out. I'm left with 5 times 4 divided by 2 times 1, which is 20 divided by 2, which is 10. So there are 10 different possible ways of having that rhyme scheme. So let's talk about some subtleties. Some subtleties. Subtleties. How I know whether to choose, permutations or combinations. So my wife likes to knit. My wife knits, and she, always has, let's say, 10 different colors on her. And when she's working on different projects, she needs to choose a bunch of different colors. So you might say, okay, she's working on some project which has 3 colors. How many ways can she choose the colors? Well, it depends. Maybe she's making something like a hat, and it's just going to be sort of bands of color. And let's say she doesn't really care about the order that she does things in. Then this is a combination. So her answer here would be she's choosing out of 10 colors, she's choosing 3, and this is equal to whatever. This is equal to 10 factorial divided by 3 factorial times 10 minus 3 factorial. And let's just believe you me that this number is equal to 120. Just you can compute that yourself. But let's suppose that she's knitting, say, a toy or something, like a bird. And so she needs, say, a color for the beak, and she needs a color for the body, and she needs a color for, I don't know, the eyes, or something like that. So the order actually matters. If she gives it a red beak and a blue body and white eyes, that's different from having a white beak, a blue body, and red eyes, or something like that. It's completely different. So here the order, or the arrangement of the colors matters because she'll get different birds, she'll get different birds with different arrangements. She could have, here's a red bird. No, I'm not even going to bother drawing this because I don't really have time. I like to draw pictures, but you know what? I don't have time to draw a picture. Pretend that I drew you a pretty picture. If YouTube didn't restrict me to 15 minutes, my videos would be full of pictures, and I would just be talking forever. So you can take that for what it's worth, you know, good or bad. Anyways, so the number here would be 10p3, which is 10 factorial divided by 10 minus 3 factorial, because this is a permutation, the order matters. And this works out to be 720. I encourage you to make sure you see why that is. Okay. So just make sure you recognize whether the order or the arrangement of things that you're choosing matters or does not matter. Now let's see some more sort of sophisticated things, how multiplication, the multiplication rule, can play into what we're doing here. So for example, let's start with one example. Let's look again at poker, and let's say I have a 5-card hand, and I end up with 3 aces and 2 kings. Now again, when I have a hand, the order doesn't matter. I can rearrange the aces and kings, so this is going to be different from, you know, first of all, that even though this looks kind of like the poem example, it's nothing like it because the order that I put my cards in doesn't matter. The other thing is that I'm choosing 3 aces out of 4 and 2 kings out of 4. So this is 3 aces of 4, and this is 2 kings of 4. So this is really 2 operations. Operation 1 is to get 3 aces of 4, and operation number 2 is to get 2 kings out of the 4 that we have. So I need to figure out how many ways I can get 3 aces out of 4 and how many ways I can get 2 kings out of 4. Again, order doesn't matter, so the way of getting 3 aces out of 4 is, it's going to be 4 choose 3, which is 4 factorial divided by 3 factorial times 4 minus 3 factorial. This is 4 factorial divided by 3 factorial times 1 factorial. 1 factorial is just 1, so it's 4 times 3 factorial over 3 factorial. Those cancel, so I've got 4 ways of choosing 3 aces. How about how many ways do I have of choosing 2 kings? That's 4 choose 2, which is 4 factorial over 2 factorial times 4 minus 2 factorial. That's 4 factorial is 24, 2 factorial is 2, and 4 minus 2 is 2, and 4 minus 2 factorial then is 2 factorial, which is 2. So 24 divided by 2 times 2, which is 4, so I get 6. So the number of ways for me to get an ace, 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 king, king is 4 ways to get the 3 aces times 6 ways to get 2 kings is 24. So there are 24 ways for you to have 3 aces and 2 kings. Let's do something a little bit different. Let's again look at a test that I'm putting together, and in my 104 classes, let's say I have 20 possible questions, and let's say I want to choose 10 of them to be multiple choice and 5 of them to be written. You may say, oh man, why can't we have multiple choice? Because multiple choice, you'd rather have written because I can at least give you partial credit. Anyways, when I arrange the questions on the test for them, I always do it like this. I take the page and I put 2 multiple choice questions at the top and a written one at the bottom. So really all I care about is how do I arrange the multiple choice questions and how do I arrange the written ones. You know, what order do I put the 5 written ones in? What order do I write the 10 multiple choice ones in? Because once I choose those orders, then they, you know, get laid out according to this page layout. So this is my page layout. So I've got two operations. My first operation is to choose, and let's suppose that any question can be either multiple choice or written. I can, change them to be multiple choice or written. So one option is to choose 10 questions to be multiple choice from the 20. And then my second operation is to choose 5 written. Well, I've already chosen 10 questions to be multiple choice, so I've got 20 minus 10 equals 10 questions left. So I'm choosing 5 written from the 10 remaining questions. From the 10 remaining. Okay, well, how many ways do I have to choose 15 questions out of, or 10 questions out of the 20? Since I care about the order of the multiple choice questions, it's it's 20 P 10, which I'm just going to write this out quickly. It's 20 factorial over 10 factorial. And the number of ways of choosing the 5 written questions, excuse me, that should be a 10. The 5 written questions out of the 10 remaining questions is P of 10, 5. So I get 10 factorial over 5 factorial, and the total number of tests I get here is 20 factorial over 10 factorial times 10 factorial over 5 factorial. Let's just note that this works out to be 20 factorial over 5 factorial. Now, I could have chosen things in a different way. My first operation could have been to choose 5 written. I keep doing that, sorry. 5 written out of 20 total. And then my second operation could have been to choose the 10 multiple choice from the 20 minus 5 equals 15 remaining. So how many ways do I have of choosing 5 written from 20 total? This is 20p5, which I'm just going to write this down quickly, is 20 factorial over 15 factorial. Make sure you can figure that out. And 2, the number of ways of choosing 10 multiple choice out of the 15 remaining is 15p10, which is going to be 15 factorial over 5 factorial. Again, I'm just doing that quickly. Make sure that you can see why that's the case. So what happens when I multiply those two numbers together? The total number of tests is equal to 20 factorial, this time it was 20 factorial divided by 15 factorial times 15 factorial divided by 5 factorial. Canceling that out, I get 20 factorial divided by 5 factorial. This is the same number. So what I'm showing here is that it doesn't matter the order that you do the operations in. You might count things in different ways, but you still get the same answer. So there is not necessarily one way to get to the right answer. Okay. Let me just write down one more problem, and again, I will finish it in the next video because I've only got about 1 minute left. So let's suppose that I have a committee. This is exciting, a committee of 10 people. And we're going to choose a subcommittee of 5 people. And there will be one chairman or woman, so chairperson, and there will be one secretary, just the person who makes the notes. So how many subcommittees can we form? Okay, think about it.